Welcome students. Today we are going for the next topic in current electricity, that is called potentiometer. What exactly is potentiometer? We will first of all try to understand. Potentiometer is just consisting of a thin, uniform, long wire which is stretched over a wooden board. So wire has to be thin so that it has comparable value of resistance. It has to be uniform in its area of cross section, and the wire should be as long as possible. Whereas in experiments we take 4-meter length of a wire, but if you have more length of wire, it will be giving you more accuracy, and it will be giving you better results as well. Now, what this instrument actually is, as we said, it's just a thin, uniform, long wire. What can it be used for? What are the applications of it? We can understand that potentiometer, as the name itself is indicating, the potentiometer can be used to, first thing is, measure small values of potential differences. It can also be used to measure small value of EMF. What's more important is, as name itself is saying, it's potentio, that is potential difference. Meter is measuring potential difference. The advantage of using potentiometer over a normal voltmeter, even we can measure potential difference by using a normal moving coil type of voltmeters, but by using potentiometer you can measure EMF of a cell, which you cannot normally do it by using a voltmeter, because when you connect a voltmeter across a cell, it draws practically some current from the cell, and that is how it gives you the reading of a potential difference rather giving you an EMF. So by using potentiometer, we are using it in such a particular way that it is not drawing any current from the cell whose EMF I want to measure, and that's how it gives you the value of EMF. Anyway, during the study of its applications, we will actually understand what we mean by this. If you have two cells, you can even compare what is the EMF of those cells, and most important, one more application is that you can measure what is the internal resistance of a cell by using potentiometer. We'll first of all understand what is the principle of working of potentiometer. Potentiometer principle of working states that for a potentiometer wire carrying steady current through it, that is very important part of it, that every time a potentiometer wire carries a steady current through it, the potential difference between any 2 points on the wire is directly proportional to the distance between them, or the other way of stating it is that whenever potentiometer wire carries steady current through it, it has got a uniform potential gradient. What do I understand by a potential gradient? Potential gradient is just potential difference per unit length. So the third way of stating it is the same thing, that for a potentiometer wire carrying steady current through it, the potential difference per unit length is always constant. What I mean by this is that once I have a look at the diagram, if I have a look at this diagram in this figure, I am showing that AB is a potentiometer wire that we have, and that potentiometer wire AB that I have has been connected to a battery key and some additional rheostat like resistance in the circuit. So this battery will have, once the key is inserted, it will have some current, and as long as you don't change any other resistance values in the circuit, the current will remain constant in the circuit. So if at all RAB is the resistance of this particular wire AB, there will be voltage VAB across it. Let's say, for example, I take into consideration the length of this wire AB is equal to, let's say, 4 meter or 400 centimeter in this length of wire, and let us assume that the voltage between point A and point B is about 4 volt for our understanding purpose. So if B is at 0 potential and if A is at 4 volt, then in that case, the statement of the principle of working tells you that the potential at point A is gradually going to decrease from point A to point B. It will keep on decreasing. such that the VAB, that is 4 volt divided by 400 centimeter, that is 4 divided by 400 is 1 upon 100 is 0.01 volt per centimeter, is called the potential gradient or potential difference per unit length. What we actually understand here is that for every 1 centimeter length, as you move along this potentiometer wire from point A to point B, the potential will drop by 0.01 volts, such that if A is at 4 volt, after 1 centimeter length, the potential will be 3.99, next 1 centimeter it will be 3.98, 3.97, 3.96, and so on. The potential will keep on dropping down, so that the midpoint of this wire AB will be at 2 volt. So A to B, A to that midpoint, if I call it as M, the potential difference will be 2 volt, that M to point B, it will be 2 volt. If I choose any other point on this wire, say let's say this is point B, the potential difference between A and P is equal to the potential gradient multiplied by its length. That's 0.01 multiplied by length of this wire AP. That's a very simple idea for us to understand in this potentiometer. Well, instead of first of all going for mathematical proof, I have given you a rough idea of what it is. The mathematical proof of that can actually be studied, that if I have say I is the current flowing, then I is always equal to VAB divided by resistance of wire AB, and then in that case the potential difference, if I choose any point P, we can derive this mathematical equation that the potential difference between point A and P is directly proportional to distance between point A and P, that is length small l, such that VAP is always equal to this value K multiplied by length L. So in general, if I choose any point, even Q on this wire, if I take into consideration, if I choose any other point Q over here, supposing here, then potential difference between P and Q will be equal to that K multiplied by distance of PQ. If you have any other point R over here, then that is voltage between P and R, that is equal to K multiplied by length of PR, where K is equal to the potential gradient. So what I must understand is that in case of potentiometer, the potential difference between any two points will be always directly proportional to the distance between those 2 points. Greater is the separation between the 2 points, there would be greater potential, and that potential difference is equal to potential gradient into the distance between those 2 points. That is the basic thing for us to understand. Using this particular idea that V between any 2 points, A to that any general point on the wire, it is equal to K multiplied by length L, we can try and understand the applications of potentiometer. We will actually go for the application of a potentiometer. Let's say we have the first application that we are going to study is to compare the EMF of cells by using sum and difference method. Now what we do is, as I was saying it earlier, the potentiometer practically is of 4 meter in length. So here I have got that wire AB, which practically is seen like 4 meter in length. After 1 meter length, we have got a U-turn. Next 2 meters, 3 meters and 4 meter length of wire AB we have. Point A is connected to higher terminal of a battery. Then point B is connected through rheostat to the lower terminal of a battery. There is a key in the circuit with the help of which you can either switch on the circuit or switch it off. The purpose of this battery connected between this A and B, this is basically called that AB wire connected to battery key rheostat. This is called primary circuit, and it is always going to be there in every potentiometer experiment, because this battery is going to supply constant current in the potentiometer wire. Without this, the potentiometer cannot function. So that's the reason this circuit will be always mandatory, or it's going to be there in each and every potentiometer application, that AB battery key rheostat. Now in this upper part of wire AB, I call this circuit as the secondary circuit. Here I have got two cells, one is cell E1, the other is cell E2. They are connected as shown in this figure by using 4-way key, and now I see that by using this 4-way key arrangement, I can either connect cells E1 and E2 in the assisting position or in the opposing position. What I mean by connecting cells in the assisting position is that how we connect cells usually in our remote control or in torch, that the cells are going to assist each other. The total EMF will be equal to E1 plus E2, whereas if you have the cells sending currents in the opposite direction, they will be opposing each other. In this case, EMF will be equal to difference of these two. If I have E1 is greater than E2, it will be equal to E1 minus E2. Here we are considering cell E1 to be of a greater EMF than that of E2. So if I connect the cells right now, I find that negative of cell E1 is connected to positive of E2 and negative of E2 is connected to a galvanometer. So this is right now seen as connected in the you see assisting position. Whereas you can just connect these two keys in the remaining two gaps and the situation will be in the opposing position. What we just have to do is, once the cells are connected in the assisting position, you touch your jockey once at point A, once at point B, and you will find that it gives you both sided deflection. Then you find some point on this wire AB where the deflection of the galvanometer is 0. At this moment, the total EMF in the secondary circuit, that was E1 plus E2, that is getting balanced by your balancing length L1. If you find the null point is at length L1, then E1 plus E2 is equal to K times of L1. That is how you find. So it gives you that E1 plus E2 is equal to K times of L1 will be happening in this case. If I use the four-way key, and now if I find that the cells are connected in the opposing position, and I find my balancing length to be equal to L2 here, then in this case I find that E1 minus E2 is equal to K times of L2. That's how you get it. So if you get E1 minus E2 is K times of L2, then I can take a ratio of these two equations, that E1 upon E1 plus E2 upon E1 minus E2 is equal to you see L1 divided by L2. And if I then use my component or dividend property of equal ratios, I'll find that E1 upon E2 is equal to L1 plus L2 upon L1 minus L2. Whereas below that each wire of 1 meter length, we have got a scale fixed so that the readings of the length can be taken. Now because my galvanometer was in the balanced position, it was not drawing any current from the cells, and that's how you see the EMFs were getting balanced. Now in this case, I find E1 plus E1 upon E2 is equal to L1 plus L2 upon L1 minus L2. You can actually you see substitute these values and compare what is the EMF of cell. And because we are connecting our cells in the assisting and opposing positions, we have this method is called as you see sum and difference method. We also have YouTube link for this particular experiment. You can actually go and watch it on this particular link, https://youtube.be/bhfs capital Y capital N KEQ capital R small o. So you can go on this particular link and actually go and watch how we perform this particular experiment. Well, thank you for watching this video as well. Thank you very much.